Hello everyone, welcome back. In the previous session, we have discussed about IPv4 and IPv6 number of bits used to represent IPv4 address and IPv6 addresses, and what is the need to move on for IPv6. In this session, we are going to discuss about IPv4 classes. Before entering into the actual session, let me have a question. What is the need to divide IPv4 addresses into classes? In simpler words, it's for our convenience and allocation based on the host. As discussed earlier, the priority bit is the one which determines the class. IPv4 is divided into 5 classes: Class A, Class B, Class C, Class D, and Class E. Let's discuss about them in detail. Class A. For the Class A IP address, the priority bit will be 0. That is the most significant bit present to your left hand side will be 0, and remaining bits can be either a 0 or a 1. If you can see here in the first octet, it is represented with n. The first octet of class A IP address belongs to the network portion. So if there is any change in the network portion, the PCs will belong to the different networks. And the remaining 24 bits will be considered as your host portions. So the range of IP address will be from 32 zeros to 031 ones. If you can observe throughout the series, the priority bit is kept 0 and is not changed. The decimal notation for the range of Class A IP addresses is 0.0.0.0 to 127.255.255.255. Of all 32 bits, the priority bit is not changed throughout the Class A, and the remaining 31 bits can be either a 0 or 1. So the total number of possible IP addresses with Class A is 2 power 31. That is equivalent to approximately 214 crores. Though there are 8 bits in the network portion, that is the first octet belongs to the network portion, the only 7 bits are varied. That means the total number of networks possible can be 2 power 7, which is equal to 128. So the range of class A network is from 0 to 127. 0, 1, 2, 3, so on to 127 are belonging to different networks. In each network, there are 24 hosts, which is equal to 1 crore 67 lakhs approximately. 2 power 24 is because there are 24 bits or 3 octets in the host portion. Moving on to class B, here the priority bits are 10. That is, the most significant 2 bits are considered as priority bits. The first 2 octets belong to the network portion. Though there are 16 bits in the network portion, the 10 is fixed. So there are only 14 bits that can be varied, and the remaining 2 octets belong to the host portion. So the class B IP addresses start from 10 followed by 30 zeros to 10 followed by 30 ones. If 10 is changed, the class of the IP address will be changed. Representing them in the decimal format, class B IP addresses ranges from 128.0.0.0 to 191.255.255.255. So as 2 bits are fixed, that is 10, the total number of IP addresses that are possible with class B is 2 power 30, irrespective of the networks and hosts, which is equal to 107 crores 37 lakhs 41,824 IP addresses. Though there are 16 bits in the network portion, 2 bits are the priority bits, and remaining 14 bits can be varied. So the total number of networks possible with class B is 2 power 14, which is equivalent to 16,384, and the first 2 octets represents the network. For example, consider 2 IP addresses 128.0.0.0 and 128.1.0.0. They both belong to different networks because there is a change in the network portion. The network portion comprises of 128 and 0 for the first IP address and 128.1 for the second IP address, which shows the difference between the networks. The number of hosts possible is equivalent to 2 power 16, which means 65,536 hosts can be connected in a single network using a Class B IP address. If you can see the difference between Class A and Class B, the number of host bits are reduced from 24 to 16. That is, number of systems or devices that can be connected in a single network has been decreased from 2 power 24 to 2 power 16. That's in brief about Class B. Let's move on to Class C. Here the priority bits are 110. That is, 3 bits are used to represent the priority and 3 octets are used to represent the network portion. The first IP address of Class C starts from 110 followed by 29 zeros, and the last IP address in Class C can be 110 followed by 29 ones. The range in decimal notation is from 192.0.0.0 to 223.255.255.255. As 3 bits are fixed, the total number of IP addresses generated using Class C is 2 power 29, which is equivalent to 53 crores 68 lakhs 70,912 IP addresses. The total number of networks possible are 2 power 21. 3 octets, that is 24 bits, belong to the network portion, but there are 3 priority bits. That is why 2 power 21 networks are possible, which is equivalent to 20 lakh 97,152. In a Class C, let us consider two IP addresses, 192.0.0.0 and 192.1.0.0. These two belong to different networks of Class C because there is a change in the network portion. For example, 192.0.0.1 and 192.0.0.10 belongs to the same network because there is a variation in the host portion but not in the network portion. This means 192.0.0.1 is assigned to one PC or one device. It can be a router or PC or a firewall or a server. And 192.0.0.10 is assigned to other device, which can be a fax machine or a printer or anything. The total number of hosts present in a Class C network is 2 power 8, that is equal to 256 hosts per network. If you consider 192.0.0.0 network, you can connect 256 devices in the same network. Class A, B, and C are assigned to our local area networks. The selection of class is dependent on the size of your network. For example, if you're having not many devices, then you go with the class B or class A, depending on your requirement. If the number of devices is greater than 2 power 16 in your network, then you choose class A. If the devices present in your network are greater than 2.8, that is 256, if you have more than 256 devices, then you choose class B. You choose class C when the number of systems in your network is less than 256. Let's move on to class D IP address. In class D, the priority bits are 1110 and there is no separation of network and hosts in class D. Each and every IP address is itself a network and itself a host. There are 4 priority bits and remaining 28 bits you can represent them as a network or as host even. Decimal notation for class D range is from 224.0.0.0 to 239.255.255.255. The total number of IP addresses that can be generated using class D is 26 crores 84 lakhs 35,456. As mentioned earlier, there are no differentiation between networks and hosts. Each and every individual IP address belongs to different network and itself acts as a host. Class D is not used to assign in our local area networks but is used for multicasting purpose. Multicasting is nothing but sending a message to a group of people. For example, a group chat on our WhatsApp. Though there are many contacts on your mobile, you will be selecting a particular group of people and create a group adding all these people. Once you send a message to the particular group, It is delivered to all the people present in the group. It is similar to the multicasting. Moving on to Class E, this network, the Class E IP addresses are used for R&D purpose, that is research and development. Any new protocol design are tested first by using the Class E IP addresses. The priority bits for Class E is 4 ones. Similar to Class D, Class E also does not divide the IP address into network and host portions. The range of Class E in decimal format is from 240.0.0.0 to 255.255.255.255, which is the last IP address in the IPv4 pool. The total number of IP addresses present in Class E are 26 crore 84 lakhs 35,456 IP addresses. But none of these IP addresses are used in local area networks. They are used for research and development. And there is no network portions and no host portions. This is in brief about the classes of IPv4 addresses. Let's summarize the classes of IP addresses. Class A has a priority bit as 0 followed by 7 network bits and 24 host bits, whereas Class B has a priority bit of 10 followed by 14 network bits and 16 host bits. Coming to Class C, it has 110 as priority and 21 network bits followed by 8 host bits. Class D has its priority bits as 1110 and Class E as 4 ones. Class D is used for multicasting and Class E is used for R&D or for the future purpose. If you observe the differences between Class A, B and C, the number of network bits keep on increasing from 7 to 14 to 21, whereas the host bits keep on decreasing from 24 to 16 to 8, that is reducing the size of the network. Class A is useful for huge networks, whereas Class C is used for smaller networks. This is in brief about classes of IP addressing. In the next sessions, we will be discussing about subnet mask, network IDs, broadcast IDs, and how the system identifies the network of a particular IP address. Thank you. Let's meet you in the next lecture.